In lesson 80, we look at direct variation as a ratio and inverse variation as a ratio. We have already been doing problems of direct variation and inverse variation. So for our basic direct variation, what we've been doing is, say, some number would equal k times some other related topic, okay, or related item. And that would be our direct variation. Then for our inverse variation, we'd have the number would equal k divided by whatever is related to it. And now we're going to set it up as ratios and proportions. So we'll still get the same answer both ways, but you may find that for different situations, one might be better to use than the other. So in example 1, A varies directly as B. If A is 50 when B is 5, what is the value of A when B is 7? Alright, so what we would do to set this up as a ratio, my A sub 1 over my A sub 2 would equal B sub 1 over B sub 2. So this is direct variation where my sub 1s line up on top and sub 2s line up on bottom. And then I simply fill in the information that they give me. So when A is 50, B is 5. So I'd have 50 on top over here, and then 5 on top on the other side of the equal sign. And we're looking for what value of A when B is 7, or what is the value of A when B is 7. So I'm looking for this A sub 2, I'm going to say B is 7. So then I could cross multiply and divide. So I would have 7 times 50 equals 5 times A sub 2. Then I would divide both by 5. So A sub 2 would equal, if you cancel out those 5s, that would be 10. And then that would be 70. So A sub 2 is 70 whenever B is 7. Okay, so you get the same answer, but this, again, might work better in certain cases. Alright, example 2, again, cost is varying directly. So this is going to be lining up our sub 1s and sub 2s. Cost varies directly as the number purchased. If 12 can be purchased for 78, how much would 42 cost? So, let's see. I have 12 for 78. I'm trying to find out how much 42 would cost. Alright, so then I cross multiply and divide. So this would be 12 C sub 2 equals 78 times 42. Divide both sides by 12, and then C sub 2 will equal $273. Okay. Now the third example has inverse variation. So it is not going to line up with your both your sub 1s on top and sub 2s on bottom. You're going to have one side with your sub 1 on top and the other side with the sub 1 on bottom of the ratio. Blues vary inversely as yellows squared. So we've thrown in that squared variance also. If 100 blues go with 2 yellows, how many blues go with 10 yellows? So let's just do the setup here for the inverse variation with ratios. So I've got blues vary inversely as yellows squared. So I'm going to have yellows with the sub 2 on top, but it's also squared. And then yellows sub 1 on bottom and squared. So they'll both be squared, It's just now your sub 1 is going to line up with the other sub 2, and then same way for the top. So for the other one, they're flipped over. Okay, then we would simply substitute in our information they give us. So 100 blues go with 2 yellows. So 100 blues go with 2 yellows. Now, these are both sub 1, so this would be B sub 1, and that would be Y sub 1. So that 2 yellows goes on the bottom, and it's going to be squared. Okay. How many blues go with 10 yellows? So that's going to be on top and squared, and then we're seeing how many blues would go with that. So we're going to cross multiply and divide. I'm going to simplify this fraction first. This would be 4. That would be 100. So I would have 400 equals 100 b sub 2. Then divide both sides by 100. So b sub 2 is going to equal 4. And then that would be our answer. So you can see, if you wanted to, you could set it up this way, just to see if you're really getting the same answer. But I do like the idea of using ratios and proportions because they work with so many different topics and concepts that we've gone over. Right, hopefully this helps, and if you have any questions, feel free to email me or ask me in class.